So let's suppose we have the following experimental setup. First, we take water and we pour water into our container, and then followed by that, we pour oil. So we have the following U-shaped container. After we pour our two substances come to static equilibrium. And note that the two substances don't actually mix. Now also, our container at both ends is exposed to our atmosphere, and that means the pressure created by the atmosphere is exactly the same at both ends. So knowing the density of water is 1,000 kilograms per meter cubed, we'd like to calculate the density of the oil. So let's begin by noticing that the vertical distance of the oil along the column is 30 centimeters. So let's choose point A to be the point between the oil and the water. And if we draw a horizontal axis along point A, it will pass through some point along this section of the tube, and let's call it point B. Now notice the vertical distance between point A and point B is 0, and so that means the pressure at point A and point B is exactly the same. So that means we can choose the pressure along this horizontal axis connecting point A and point B to be some arbitrary pressure. So let's choose the pressure along this axis to be equal to 0. So that will allow us to calculate the density of the oil in a very simple way. Because the pressure along this axis is 0 and the pressures along or at each end is the same exact pressure, to calculate the density, we simply realize that the pressure created by the oil, which is a height of 30 centimeters, is equal to the pressure that's created by this height of water beginning at point B and ending at this point, which is 3 centimeters below the point of the oil. So that means this entire section is 30 minus 3 centimeters, so 27 centimeters. So once again, the pressure created by the oil that has a vertical distance of 30 centimeters is equal to the pressure created by the water, which has a vertical distance of 27 centimeters. So the pressure due to the oil is equal to the pressure due to the water. So we replace the P's with our density, our G, the gravitational constant, and the change in vertical distance. So notice that G's appear on both sides, so we can cancel them out. And now in this equation we solve for the density of oil. So density of oil is equal to the product of the density of water multiplied by the ratio of the water's distance to the oil's distance. And notice, because the oil's distance is higher than the water's distance, this fraction will be less than 1. And so that means the density of oil should be less than the density of water. And that makes sense because it requires more oil to create the same exact pressure as created by this water. So let's actually solve for our density. The density of oil is equal to the density of water, 1,000 kilograms per meter cubed, multiplied by our fraction. So 0.27 meters divided by 0.3 meters. This fraction becomes 27 divided by 30 multiplied by 1,000, and we get 900 kilograms per meter cubed is the density of oil, which makes sense because we said the density of oil should be less than the density of water.